let's do a couple examples of using the elimination method to solve a system of equations. This says solve the system of linear equations using the elimination method. So remember, elimination method means that we're either going to get rid of the x's or get rid of the y's. So we're going to either add or subtract to eliminate one of the variables, x or y. Now, so we have a choice here, right? It's either x or y. So we want to look at the coefficients. That's what's going to be important here. So the x's already match up. The y's do not. Now we could get the y's to match up, and I'll do that as an example just later. So we'll already plan on doing it. Try again with eliminating y, but let's do it the easier way first. I want to show you that both ways would work, but easier is, often better. So I'm going to just rewrite this. 2x plus 4y equals 6. Now the second equation, we can either leave it as it is and subtract, or we can multiply both sides by -1 now. And for a lot of people who mess up their minus signs, that's an easier way to go. So I'm going to do that. Let's multiply every term by -1. -2x minus 3y equals -8. Because now when I add the equations, I get 0 x's. I've eliminated one of the variables. We want to get these coefficients to be one positive, one negative, so it adds to 0. That's the whole goal of this. And then we just see what else is left, right? So I got the x's eliminated. With y, I have 4y minus 3y. That's just 1y equals -2. Well, that's already solved. Y equals -2. To find x, we use the first equation to find x, and then the second equation to check. So let's find x by plugging into the first equation. 2x plus 4 times -2 equals 6. So that's 2x minus 8 is 6. I add 8 to both sides. 2x is 14. So that makes x equals 7. All right, so we got y equals -2. We got x equals 7. Let's check. So since I used the first equation to find x, we're going to use the second equation to check. And I'm going to use the original equation without all the negatives. For one, because, who wants to deal with negatives? But also because in case I made a mistake multiplying by -1. So up here, it's 2 times the x value we solved for, plus 3 times the y value. And I want to know, does that equal 8? So that'd be 14 minus 6, which does equal 8, so it checks out. Now on here, our answer is the point 7, -2. Because remember, the solution to a system of equations, we're literally finding where two lines cross, which is a point. All right, so that's the easier way to go, because I noticed that the x coefficients already matched up, so all I had to do is make one negative, and it worked out pretty nicely. But I want to show us the harder ways just so that we see what's going on, what this elimination method's doing. So let's try it. Eliminating y. So I would need to get the y coefficients to match. Y coefficients. By coefficients, I mean the number in front of y to match, but with one positive, one negative. It's sort of like finding a common denominator. So here I have a 4 and a 3. I'm going to try to make them both 12. So I'm going to make the one positive 12y and the other negative 12y. So that way I'm trying to make 0y. We have to sort of plan in advance what we're trying to do in order to know why we're doing what we're doing. So I'm trying to get them both to be 12, and I picked 12 because 4 times 3 is 12. And I want one to be positive, one to be negative, so when I add them, they eliminate. So let's try that. So the first equation, if I want 12y, I need to multiply by 3. So we're going to take 3 times equation number 1. So 3 times 2x is 6x. 3 times 4y is 12y. Oops, make sure to put the y in there. And 3 times 6 is 18. Make sure to also multiply the number. That's really easy to forget. We have to multiply everything by 3 to make it a valid equation, the same equation. Then if I want negative 12y here, I need to multiply the second equation by negative 4. So negative 4, and it might help to even write it up here. Negative 4 times this. It's going to be negative 8x minus 12y equals negative 32. So I took everything times negative 4. You can tell already this was a lot harder than this one, right? They set it up to make it easy to eliminate x and to make it hard to eliminate y. But we need to know both ways because it's not always going to be handed to us that x is easier. But we got these y's where one's positive, one's negative. They eliminate, they're gone, 0y. But now I gotta deal with everything else. So 6x minus 8x is negative 2x. And then 18 minus 32 is negative 14. So I have negative 2x is negative 14. I divide both sides by negative 2. So x is positive 7, which is exactly what we got here, right? That, again, we're not getting a different answer. It's the same answer because it's the same system of equations. It's just a different way to get there. So I'm not going to keep going. You can plug in and find y and check the same way we did over here. I just wanted to show you why it was so much more difficult to eliminate y than it was x. So in this example, let's see if we can figure out which one's going to be easier to eliminate, x or y. So that's the thing with the elimination. We need to pick x or y to eliminate. And really what we should be looking for is what's going to be easier to get the coefficients to match. Matching coefficients, those numbers in front of the variables. All right, so we can get the x's to match. If we did that, we'd need to make them both 6. We could totally do that. Or actually, we'd want one to be positive 6, one to be negative 6. It's doable. But if I look at the y's, I already have it set up where one's positive, one's negative, which is nice. And 5 goes into 10. So all I have to do is multiply the first equation by 2. So it's possible to eliminate x, but it's going to be much easier to eliminate y. So our goal is to get 10y and then negative 10y so that when I add them up that we get 0y, right? Right now if I added them, I'd get negative 5y. That wouldn't work. I need to get it so it's going to be 0. So to do that, I'm going to multiply the first equation by 2. So let's see what that looks like. It'd be 6x plus 10y equals 16. This is the same equivalent equation as because I multiplied every term on both sides by the same number. The second equation I'm just leaving alone because I already have what I'm looking for, which is a way to get the y's to eliminate. Because I have plus 10y minus 10y is 0y. That eliminates. But then I have to add everything else, right? That doesn't mean I'm done. It just means I've set it up right. 6x plus 2x is 8x. And then 16 plus 12 is 28. So if 8x is 28, divide by 8, that means x equals, and oh my gosh, we get a fraction. So let's not freak out about our fractions. So if you put in, so one option is to use a calculator, 28 divided by 8, great, you get a fraction, that's fine. The other is just to reduce the fraction. To say divide by 4, divide by 4. So this is 7/2, or if you need to use a decimal to make yourself feel better, that's fine too. But if this were a repeating decimal, I would want you to use a fraction and to keep a reduced fraction as the answer. But let's use 3.5, that feels better. All right, so to find y, we're not done yet. We found x, but now to find y, we're going to plug into the original equation. So find y. The original equation is 3 times x, so 3 times 3.5, plus 5y, and I don't know what y is. That's what we're trying to do, is 8. So if I multiply 3.5 times 5, I get 10.5 plus 5y equals 8. I need to subtract 10.5 from both sides. So 5y is negative 1.5. Good thing I was using my erasable pen. No, wait, 2.5. What am I doing? Negative 2.5. Divide both sides by 5. So we get y is 1/2, or, well, negative 1/2, or negative 0.5. Ooh, sorry, I'm moving off the screen. All right, we should always check. So let's check. We found y. So to check, we're going to use the second equation, because I just used the first equation to find y, so the second equation is good for checking. So it's 2 times x, so 2 times 3.5 minus 10 times y, 10 times negative 0.5, and we want to know, does that equal 12? 2 times 3.5 is 7. Then half of 10 is 5, but a negative times a negative makes it a plus 5 equals 12. That totally checks out. So yes, our answer, our solution, is the point 3.5 comma negative 0.5. It's always x comma y. If you want to get really fancy, you could even put the point in curly brackets to say it's the solution set is that point.